SRFC, I think. So I am.
Sri
Sorry,
Ramchandra Medical.
sorry, SRMC and West End Eye Hospital, Cochin. And I don't think anybody needs, sir needs an introduction to anybody. So, sir, stage is all yours. Looking forward to your three.
Thank you, Nilesh. Thank you so much for the kind introduction. I would like to thank AIOS and YOSI for organizing such events. This is a very useful platform for all the youngsters who never knew what all the are the possibilities in ophthalmology. So very much thankful that we are having such a platform. Is my screen visible?
Yes, sir.
Okay. So I'm going to talk about my first 3D print. I'm Dr. John Davis Akkara, and I'm working as a glaucoma consultant in Sri Ramchandra Medical College, Chennai, and also Western Eye Hospital, Cochin. I think many of you must be familiar with 3D printing by now. There has been a lot of innovation in 3D printing in the past few years. They are 3D printing even houses. So making a three-dimensional solid object from a digital file is the simplest definition of a 3D print. So if you see on the right here, this is a filament-based 3D printer, which is printing a model of a hand. And it is made by laying down layer after layer of the material. So this is the basic principle. This can be done in plastic, resin, metal, concrete, even ice cream or chocolate, all these things. These are the two most common, easily accessible 3D printers. This is a filament-based printer, also known as an FDM printer, fused deposit modeling. And this is the one which I'm going to be talking about. This is the one which most people are familiar with. Also, I recently used resin printers, which is also not difficult to find, and it is available very easily in Amazon and everywhere. It costs around 30,000. This one, this is more expensive, but cheaper ones are also available around 20,000. You can get the low end models. So if you want to get started with 3D printing, what you need to do is the fastest way is to just download and print. So if you go to MakerBot Thingiverse, this is where I started from, or if you go to National Institute of Health 3D Print Exchange, you get medical related 3D models, or so many websites, Free 3D, NASA has a 3D page. All these places allow you to download and print your own 3D models designed by other people and shared. You can also design your own 3D models by using these softwares. Many of them are free. FreeCAD, Fusion 360, Tinkercad, SketchUp, all these are free softwares. So you can just go to this website, search for what you want. If you find something interesting, download and print. As simple as that. This is one of the ophthalmic designs. This is from ODocs. This is from an ophthalmologist in New Zealand. He designed it and uploaded it on Thingiverse back in 2015. So this is something which anybody can download and print. If you want to design, you can go to tinkercad.com, do it online, or you can download Fusion 360. If you want a free version, just provide them with an .edu email address. Or you could use FreeCAD, which is what I used. So this is FreeCAD. And recently I designed a glaucoma valve. I had made a design for a 3D printed glaucoma valve, and it was done using FreeCAD. And this is a design for a forceps. So if you have any idea for any instrument or anything like that, just think it, draw it, and just draw it in 3D. You can prototype it. This is the workflow of 3D printing. First, you design in CAD, or you can download, export as STL or step files, and use a slicer software. All these are free software, and it generates the supports. So if you see this, the empty spaces have to be filled in with something which can be broken away, that is support. Generate the G code, send it to the printer, and the printer will print it like this, layer by layer. It might take between 30 minutes to 30 hours, depending on the size of the print and the fineness at which you are printing. So once you print it, you can remove it, break off the supports. That is the base. You break it off from the base, and then you remove the supports. Okay, you might have to break off the supports with some force if it is such a print, but then you are ready. This is what I printed first in Arvind Eye Hospital, Pondicherry, because of Dr. Rangaraj Venkatesh sir. We got a 3D printer just before I finished my fellowship. So the first thing which we printed there was this smartphone fundus camera. The very next day was the hospital day, so we printed it and presented it to the chief guest on the hospital day. This is how we could take fundus photos with the device. This is another thing which I printed while I was in Ramchandra. I was working on a device, a head-mounted device. So this is a case into which we put all the electronics of the Raspberry Pi and ultrasonic sensors. So this case I designed and printed here. This is the glaucoma drainage device which I had designed and printed. And this is a slit lamp adapter Dr. Ahmed Ataya had designed. This is an Egyptian ophthalmologist. So the basic thing is you measure, draw it in 3D, print it, and this becomes a slit lamp adapter, smartphone slit lamp adapter. There are several other things which we printed. So this is a spectacle. This is a eye drop helper by Dr. Annamalai and Dr. Shivagami, and so many other adapters. I have put all this together in an article in Kerala Journal of Ophthalmology. And if you look, there are so many other things which you can do in ophthalmology with 3D printing. This is just some of the things: spectacles, lenses, even moisture chambers. So all these personalized things are ideal things that can be done with 3D printing because they can be customized. So eye model for fundus viewing. This is one model. Dr. Rajesh Vedachalam here, he has also designed some 3D printed models of eyeball for practicing examination and even vitreoretinal surgeries. For this is also available for orbital dissections, and these things which are being sold in retail by this company Bionico, they are also supposed to be 3D printed models. And there are surgeons who say they have designed forceps and other instruments with the help of 3D printing for prototyping. You can even 3D print in metal if the need arises. This is a transconjunctival vitrectomy trocar, which was initially designed with 3D printing. This is Dr. Sergio Canabrava. He said he designed the Canabrava ring using 3D printing initially. This is a glide, a smart storage glide for DSEC. This is another 3D print artificial anterior chamber. Dr. Rajesh Vedachalam has made this. And for anterior segment imaging, an attachment was made this is the same doctor who made the Odox fundus. And this is the one which we printed from Xiongchang. And this is another one. This is designed by Dr. Ahmed Ataya. And all these things have been designed by people who had not much experience in engineering. So this is a 16-year-old girl who designed this smartphone fundus camera. So everything is simple. All these things you can simply draw. If you have an artistic eye, you can do it. 3D printed prosthetic eyes are also available. You can, take a CT scan and use that to make the appropriate size and shape devices. So all these orbital implants for children, 3D printing has a big role to play. And not last but not least, bioprinting is going to come up in a big way because then you can 3D print the cornea